Hi, in this lesson we will cover domain and range of common trigonometric functions. So let's get started with it. What is domain? Domain is the set of all independent values of x that a function is defined for. Range is a collection of all the outputs of a function corresponding to the values of x from the domain of the function. Okay. So we'll talk about all the common trigonometric functions. So namely sin x, cos x, tan x, and their inverses. Okay, let's put in the domain here, and we will also write what the range is for each of these functions. Okay. We will probably need to refer to graphs of at least sin and cos. So let's quickly draw that. So this is the x-axis, this is the y-axis. This is obviously 0 origin. Okay. Now how does function of sin x look like? Sin 0 is 0. Sin pi by 2 is 1. Sin pi is again 0. Sin 3 pi by 2 is minus 1. Sin 2 pi is 0, and it goes on like that. So if we plot the function of sin x, it increases from 0 to pi to 1 at pi by 2, then again decreases to 0 at pi, goes up to minus 1 at 3 pi by 2, decreases to 0 at 2 pi, goes up to 1 at 5 pi by 2, goes to 0 at 3 pi. Okay, so this is sin x. Now, what would be the domain of sin x? It is defined for all positive and negative values of x. So we can say domain of sin x is open brackets minus infinity to infinity. Okay. How about the range? It's pretty clear that sin x maximum value that it can take is 1, and the minimum value it can take is minus 1. So the range is minus 1 close bracket to 1 close bracket. Okay. Now let's look at graph of cos x. Again, this is 0. Now cos 0 we know is 1. Cos pi by 2 is 0. Cos pi is minus 1. Again, cos 3 pi by 2 is 0. So if we plot the graph of cos x, it goes from 1 to 0 at pi by 2, minus 1 at pi, to 0 at 3 pi by 2, to 1 at 2 pi, 0 at 5 pi by 2, and such. Okay, so this is cos x. Now let's look at again the domain, and this is exactly symmetrical on the negative axis, similar to sin x. So domain of cos x is minus infinity to infinity, and range again it is bound between 1 and minus 1, so the range is minus 1 to 1. Okay, simple so far. Now let's move on to tan x. Tan x we know is defined as sin x divided by cos x. So tan x would be undefined whenever cos x is 0. And when is cos x 0? Cos x is 0 at pi by 2, 3 pi by 2, 5 pi by 2. So all odd multiples of pi by 2. So tan x is undefined at 2n plus 1 pi by 2, and it is defined for everything, all real numbers, minus 2n plus 1 pi by 2. Now let's look at what values tan x can take. Okay, so let us also plot the graph of tan x. So tan x at x equals to 0 is 0. tan pi by 2, so sine of pi by 2 is 1, but cos of pi by 2 is 0, so it is undefined or infinity at pi by 2, right? So if you plot, you will see that it increases to infinity, goes down to 0, and then at even minus pi by 2, similarly it goes to minus infinity. Similarly, so this is the graph of tan x. Now if you look, tan x can take all positive values, positive y values, and all negative y values. So its range is minus infinity to infinity. Okay. Now let's look at three other functions, which is inverse of sin x, cos x, and tan x. So let's go with cosec x first. Cosec x is 1 by sin x. So obviously cosec x will be undefined when sin x is 0. So all real numbers minus when is sin x 0. Sin x is 0 at 0, pi, 2 pi. So it is 0 at n pi, where n is the set of natural numbers. Okay. Now what values can cosec x take? So again, this is inverse of sin x. So 1 by sin x. So let's look at this a little bit closely, okay? Sin x value, like we know, can be from minus 1 to 1. But since it's in the denominator, I'll just use this space for a while. So anything, let's break it up. Anything divided by a number x when the number is greater than 0 but less than 1, what happens, right? If it is 0, it's undefined. If it is 1, it's 1. But any value in between, more closer it is to 0, more higher the number becomes, right? Like for example, 0.1 divided by 0.1 is 10, but 1 divided by 0.01 is 100. So it can actually take up very high numbers, more x is close to 0. And more x is close to 1, it will tend towards 1. So mostly this range will be from 1 to infinity. Okay. Similarly, when x is greater than minus 1 but less than 0, this range will become minus infinity to 1. Okay, so that's the reason cosec x range is, we can write 1 comma infinity union minus infinity to 1. So these are the values that cosec x can take. Its range is minus infinity to minus 1 union 1 to infinity. Okay. Similarly, let's quickly do sec x now. Sec x, like we know, is 1 by cos x. Now it will be undefined whenever cos x is 0. And when is cos x 0? Cos x is 0 at pi by 2, 3 pi by 2. So all odd multiples of pi by 2. Okay. And what is the range? Range will be similar to how cosec x is, minus infinity to minus 1 union 1 to infinity. Lastly, we look at cot x. Cot x is 1 by tan x. So it is undefined for whenever tan x is equals to 0. When is tan x 0? Tan x is 0 at 0, pi, 2 pi and such. So it is r minus n pi, similar to cosec x, that's the domain. However, what's the range? Tan x can take minus infinity to infinity. So cot x can also take all ranges of values, minus infinity to infinity, because 1 by tan x is cot x. Okay, so that is all for domain and range of trigonometric functions. Once we are confident about what domain these functions are defined for and what values that they can take, then we can go up to other advanced studies on trigonometry and it will all make sense. Thank you.